Okay, now we're going to simplify radicals, but instead of estimating the answers, I want to make sure we get an exact answer. I want to do a real quick reminder of what an irrational number is. An irrational number is a number like pi. Pi is equal to 3.141592653 blah blah blah, and goes on forever and ever, and it never stops. I could never write that. Anytime I write pi, I use some sort of estimate of pi. This is an example of an estimate. I stop there. 3.14 is an estimate. It's not exact. That number can never be written. So you're always using an estimate, except if you leave it in terms of pi. If I leave the symbol pi in there, that's exact. It stays in there and it's exact. These square roots, they're typically irrational numbers whenever we're trying to simplify them. So to have exact answers, our answers are still going to include the square root. So let's go through and set up how we're going to find these square roots. The first thing I want to do is make a list of perfect squares. To make a list of perfect squares, I can use the calculator. So in my calculator, I can go to, let me turn it on, go to y equals, and I can put in x squared. X squared gives me a list of my perfect squares when I go to the table. I can go up to, let's start at 0, and here are my perfect squares. So I'm going to fill in my perfect squares on this table. For 1, I have 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 36, 49, 64, 81, and 100. Those are my perfect squares. To find the square root of these numbers, I'm actually going to have two examples here. So let's see if we can simplify these. First one we're going to look at is square root of 5. What I'm going to do is I'm going to find that over here in my perfect squares. I'm going to start here and look for it. Do I see that in my list of perfect squares? There is no 5. So it is not a perfect square. What I am going to do is I'm going to find where it would fall. That 5 would fall about here, right after the 4. And what I have to do is I have to divide my 5 by each of those numbers below it. 5 divided by 4, 1.25. I'm looking for whole numbers. That's not a whole number. That can't work. 1 doesn't matter. So I cannot simplify the square root of 5. The square root of 5 is simply the square root of 5. Now let's try 20. 20 we can simplify. So let's find where 20 would fall. 20 would fall somewhere in between 16 and 25. So I take 20 and I'm going to divide it by 16. Decimal number. So I'm going to take 20 and divide it by the next one. Let's try 9. 25 by 9. Nope, definitely not. Then do 20 divided by 4. And I get a whole number. This is what I do. I'm going to take, where did I get it? This 4. So I'm going to take this 4, because I was successful with the 4, and I'm going to write below the 20 the square root of 4. That's what I divided by. That's my perfect square. I'm going to write that first. And I'm going to multiply it by my integer answer that I got. That is the square root of 5. So the square root of 4 times the square root of 5 is the square root of 20. Now, the reason I split this up is because I know that I can do something with the square root of 4. I know the square root of 4 is 2. So just like this line, the first line and the second line have the same value, these two show the same value as well. The square root of 4 is the same as 2. And I know from my previous example, there's nothing I can do to 5. If you work from the largest number and go backwards, this number will always be as small as you can go. and I just simply write that in proper form, 2 the square root of 5. That is the answer.